First, I'm going to give you a quick little introduction to who Javelin is and what we do. And then we're going to have a Q&A session with Sean McTeer from Prothane. Then we're going to open that up to questions. If anybody has any questions out there, feel free to ask them. You can go on your window there at the side of the screen in the chat mode and put in any questions as we go through the webinar. And at the end, we'll pull a couple of those out. We'll probably have time for 2 or 3 questions. So Javelin, we've been in business since 1997. We're about 65 plus employees now. We have offices across the country. We started as a SolidWorks vendor, and we are the largest SolidWorks vendor in Canada. And over the years, we have expanded the different products and services that we have to help our clients do more with their 3D data. And one of those things is 3D printing, and that's what we're here to talk about today. But Javelin does have a complete 360-degree solution, including hardware, software, training, support, programming services, consulting services, etc. So we're able to help our clients do a lot with their data. We are going to talk about 3D printers today, and Javelin represents the Stratasys line of 3D printers. There's over 20 different models that we have available to us and that our clients have available through us to address a wide range of needs and a wide range of sizes as well. So we'd be happy to help anyone out with that if you're interested. So enough of the shameless plug. We want to introduce Sean McTeer. Sean is the president of Prothane. He's also a board member of the Canadian Urethane Manufacturers Association. The web address is there on the screen if you're interested in looking into that. They're also a member of the Canadian Tooling Manufacturing Association, and Sean is a certified wood and metal pattern maker. At Prothane, they have one of our 3D printers, and we're going to get into talking about that. But first, let me welcome Sean to the webinar.
Thank you very much.
First of all, I wanted to give everybody a little bit of background about Sean and his company. The company started in 1965. Sean, maybe you can tell us a little bit more about the company. And I understand it's a family company. Is it your family that started Prothane?
Not actually started. The original founder was Warren Carter. He was actually the head chemist at DuPont Canada for rubber, and he was the head chemist there at DuPont, and he got introduced into urethanes, and once he started looking at the specs sheets of urethane instead of rubber, he instantly quit his job and started up Prothane at that time. And that was in 1965. That was and still running to this day. Unfortunately, Warren Carter is no longer with us, but we're still continuing his tradition.
Excellent. So over the years, 50 years now, the company's been in business, and you've grown to 11 employees. You've got about 12,000 square feet at your facility up in Milton. Can you tell us a little bit about how you've grown your business, and specifically what kind of markets you work in and why Prothane has been successful?
We're into a whole bunch of different markets, and that probably the one that first started us off and everything was Warren Carter got involved with Bombardier Aerospace, and that was one of probably our first clients, and continuing, we're still making parts to this day for Bombardier, so it's worked out very well. And urethane is a unique aspect material because you can do as soft as bubble gum and as hard as steel. Similar products are like your UHMW, Delrins, and that, which those materials are only for hard compounds, but then if you needed softer, you'd have to go to rubber, but rubber was only good from a 60 to about 85, 90 A hardness, where the urethane, we can go softer than that, even softer than silicones, which is a 25 A, which literally is bubble gum. And that's why urethane's taken off so well, is because you can go from bubble gum to as hard as steel. So it makes it a lot of fun, and you can mold absolutely anything out of it.
Interesting. Yeah, I saw when I was at your office, I saw you have some other cool equipment on your floor there. Here's a couple of pictures on the screen now. Do you want to talk a little bit about what these are and how you guys use them?
Yeah, the one on the left is actually our newest machine. We just got a laser engraver, and this is mainly to put serial numbers on our parts, as well as to cut out jigs and fixtures, and some tooling as well too on that, as well as marking our molds and doing everything else. If our molds come in unmarked, well then we can handle things ourselves, and we can handle different aspects with the laser aspect, and it's just a lot of fun these days. And then on the right, we've got our CNC lathe for more intricate parts. In our business, we're known as not very high volume, which is nice. All of our guys, well, we'll handle parts any from 1 part to 100 to 1,000 of small little parts. But we don't like get into rollerblade wheels, let's say, is polyurethane as well. We're making billions of the same thing. We're a small shop. We like to keep it this way, and we like all of our guys to be very versatile, where they can actually start one job in the morning. By the afternoon, they've made 100 parts, and they're already on to the next job. So there's no repetition. It's not like on an assembly line by any means. So all of our guys have a lot of experience in all different parts. So with the CNC, it's just to do curvatures, rollers, forklift truck tires, that just have special crowning in that, where a manual lathe was just a little bit labor intensive. So CNC lathe can handle that, and now that CNC lathes is so user friendly that even if you only got to cut 2 parts, it's easy to program, it's quick. So that's why we got into the CNC.
Great.
Lathe part.
But you've talked a little bit about urethane, and it's a fascinating material. It's very interesting. Has a lot of different applications. I wonder if you could talk a little bit more about the types of products that are really well suited to urethane. And here's some, when we were at your office last week, these are some pictures that I took of some of the parts. And if you feel free to talk about these specific parts, or if you want to talk about other areas, that'd be fine too.
Perfect. Well, starting off, let's say the top left-hand corner is a piece for the pipeline pigging applications, which in the pigging applications, there's a lot of urethane involved in it, just because you're immersed in a lot of chemicals. You're in a dungy pipeline with a lot of foreign materials in through it. You're going through a lot of bends, and the pipeline could be bent or it could go through a lot of corners, where urethane is extremely flexible, that it can work around those corners. But also too is, for example, the one on the top left is pretty much like a cup or an umbrella in a sense. So during the pipeline, they want to inspect the pipeline, make sure that the steel wall doesn't have any corrosion inside of it. So the tools, the urethane parts that we make for it, is almost like an umbrella. If you don't want to stop the pipelines from having all the chemicals coming through it, so they just insert this tool in. And like an umbrella, if you push wind in behind it, well, in this case, it's your diesel fuel or gasoline fuel, pushes in behind it and drives this whole cup, which while it's being pushed through with the media that's going through the pipeline, it will measure the pipeline and tell you how thick the steel is and runs through that.
So it's both flexible and resistant to chemicals.
Correct.
That's really what makes it unique.
Yeah, and it will take a beating. For example, all of these parts here are out of urethane. You can fold them perfectly in half, crush it in a vise, and it will spring right back into its natural shape without any cracks, dents, or anything. Versus if you did that with HMW or Delrin, the part would break. So you can drive a forklift over this stuff and it just bounces back, which is nice. You can throw parts around the shop and you've got no damage.
What's the part at the top right of the screen there?
Top right is actually wheels and everything. That specific one is for ski lifts and that. And urethane is incredible for its low temperature applications. For example, obviously ski lifts, it's outside exposed to a lot of snow, Arctic temperatures and everything, and at minus 45 degrees Celsius, you'll have the exact same resilient properties as ambient temperatures. So just like your forklift truck tires, where it takes a larger beating, forklift truck tires, you don't want to actually use rubber because it can't take the extremely high loads. Urethane will do that. And even being outside, it will still take the loads without any cracks. The one in the center and the top is just a polishing shoe. So just more of a jig and fixture to hold things in the part, where the urethane is non-marking. So if you took that part and just rub it along your desk or anything like that, or the wall, it will not leave any traces of material or color or anything. So in the automotive industry, manufacturing of your vehicles, they'll use a lot of urethane just because you got a brand new car you're in the midst of making. They don't want any scratches or dents or any traceability of materials that were contacting it during the manufacturing. So urethane used as a bumper protector or protective skin. Bottom left is just a bumper plate as well too. That one's actually used for your snow plows and everything, for all different regions and everything. So it's just an angle plate. The one on the bottom right is just a mat, actually for boats and everything, and protective unit again, just protecting the boat from any scratches or dents. And like rubber, for example, if that one is out in the sun, exposed to it, rubber, as you know, will dry out and crack, and then you got to replace it. Urethane, it'll be here for 100 years from now and still in the exact same properties.
Great. So this slide here talks a little bit about the process, and that's going to lead us into how you use 3D printers. But if you can sort of describe in general terms the process of how you make parts using urethane.
Yep. First off, if you already have a mold existing, you would do a dry fit on the mold, make sure everything's good. But then you put a spray release inside of the mold to not allow the urethane to actually adhere to the mold. For example, the bottom left, or top left is the mold disassembled. We'll use aluminum or other base materials for our molding process. Then we'll close up the mold, and then you can see in the bottom left there we've got a pour spout where we'll actually pour our material in, and you can see on both sides of that there's little venting holes to release gases and airs and bubble entrapment. So once the mold is all assembled and put together, then we'll go to our metering machine or hand dispensing machine, whichever, which is the middle picture. This is a metering machine where you put in what hardness material. It will take from any of the drums that you have your materials in, formulate the mixture percentage-wise on A, B, C, D, E, and F sometimes, and mix them all into your bucket.
So you're able to custom blend a specific material for a specific application?
Correct. Yep. So depending on what hardness of material you're using different chemicals for everything. So, and then we're a custom fab shop. Whatever whatever our customer needs for color-wise. Let's say automotive industries, they need yellow for safety, red for danger areas. We can custom blend the color in it. It's just like your Home Depot with your canisters and that, and just add a little color into it. So we'll operate with 100-gram batches all the way to 150-pound batches, which is kind of rare for us. The majority of our stuff is in 2-3 pounds of material, which is nice. Once you get your material all mixed up or dispensed out, then you mix the material, and then you put actually into a desiccating chamber to get rid of your air impurities. Once that's done, then you would actually go into your oven, which is set at 212 degrees Fahrenheit, and pour the liquid urethane into your mold. From there, at 212 degrees, it would sit in there for about anywhere from 15 to 20 minutes to half an hour, depending on what material you're using at that time. In that half an hour time period, you're able to demold your part, take that out. Then you leave that part in the oven at 212 degrees for another 16 more hours to give it a cured bake. This will give you 100% properties out of your material.
That picture in the right is the oven, right?
Correct. Yeah. So it's a large oven that you just walk into, and after about 15 minutes, in your next slide there, you're demolding the part. So this is just a cone sleeve for pipeline industry and application, and just a flexible tube sort of thing. So it makes it a lot of fun.
Great. So recently, Prothane bought an Object 3D printer, and this is actually a picture of your printer in your office. What prompted you to look into 3D printing?
Going back probably about 10 years ago, well, actually longer than that, but anyways, most customers will come to us with a design, or they'll have a sample part for us to make off of, either made out of wood or a metal part of that, and they just want to replace it with urethane because of its properties. So what we would do is take that same sample part, create a reverse mold off of that by using our urethane, which works out good. Once you got the reverse mold, then you can make as many parts off of that mold as it is. Well, sometimes customers don't actually have a sample model for us. So what we would do then is get one machined out by a local machine shop for that. Or with these days now, with the rapid prototype machine, we can do it in-house, where we could actually, customer would send us the file, no matter where we are. And we have customers in Germany that email us the file over, and we just put it into Javelin software, hit print realistically, and then within that same day, you can pull out the sample model of the part. Then we can make a reverse mold that same day, and then by the following day, we're already making parts out of it.
So I think our next slide sort of addresses that. So this is a part that you printed, I believe, on the Object 30. Is that correct?
That is correct.
And what's that? Do you know what that part's for?
It's a bumper plate. Not exactly sure what it's for, but it's for pipeline applications and everything. And it would just go on the tools. So they just need a replica of that out of urethane. So what we would do from here is print the model, which that one is there. Then we would pour a reverse mold, which you're seeing now. And that just gives us the reverse image of it. And we can use urethane for our tooling. And that urethane mold there would last probably a couple thousand hits off of it, depending on if there's metal components going in it, or then it takes a bit of a wear. And that's why we've got some aluminum inserts in there, because there is a metal plate that gets installed in it. And if those pins wear out, then we just pop those out, put new pins in. But realistically, you'll get 2,000 shots out of that. Now the customer, he only needed, I think it was about 12 of these at this point in time. And over the next 5 years, they'll probably order 50 parts in total. So realistically, that mold is going to outlast the parts.
So you're using urethane to make a mold that's going to be used to make more urethane parts.
Correct.
Interesting.
As long as you put a release agent between the two, right, it will be two separate units. If you don't use a release agent, it's going to be one big solid block of nothing.
So this, I think, just shows that original part in the urethane. So just to recap, if I understand you correctly, you print a part using your 3D printer when your clients don't have an original part to work from. Do you design those parts, or you work with their designs?
Work with their designs.
Okay. So you print a part, and then you use that to create the urethane mold, which you see as the green mold there. And then from that, you can make any number of thousands of parts from it that would match the original model that you made on the 3D printer.
The advantage, too, of the 3D printer in this application was, even if the customer has a sample model of a part, but you got to keep in mind, too, is there's going to be shrinkage on the urethane as well. So because you're producing in hot ovens and everything, and you're going to get shrinkage. If you do everything cold, you get about a 2% shrink rate. Even with hot casts, 1.5 to 2%, depending on the application. So if the customer can't live, he's got to actually have exactly the size that he needs. And you only have a sample part, well then, at least in the Javelin software on the Object 30, you can actually just scale it up by that 1.5%, and your shrinkage is all taken care of. And that way, when you go to print your part, when they get the finished part, it's the exact same size again.
Perfect. So then the other option would be this example.
Yep. So instead of making a reverse mold of a sample part, we've tried other machines and everything, Z-Corp machines and that, trying making molds off of it, but the texture is too rough to be able to use their parts as a mold. But with the object materials and everything, it's such a smooth, glossy finish that we thought, okay, let's save a step. Instead of actually doing reverse molding off of it, why not just print the mold instead? So this was a unique design that we actually had to get done in about 2-3 days. So what we did is just printed the mold off of it, incorporated the shrinkage into the effect. The material that we were pouring in this one was a cold room room temperature material, so we didn't have to worry about the object material going into our hot ovens, which we later did experiments with, and we had some great results as well too. But you know, baby steps at a time. So at this point, we just did a reverse molding and created the mold, and then poured our urethane part into it. And with the release barrier between the two were able to come apart very nicely. Just air hose to pop them out.
Great. So the first example we saw, you printed the model and made a mold, and in this case, you're printing a mold directly with some inserts, slides are in there, and then making the parts. So how many parts would you be able to make with a mold like this?
Probably, because this is solid urethane and all this, you'd probably make 100 parts, and then you'd have to probably print another mold at that stage.
Okay.
Or if we're paying, although one cavity mold pouring at a time takes a long process. If a customer needs 100 of these parts in a short period of time, what we would actually do is take the orange piece, which we already have the model of that one, and just create urethane molds off of it. And then if we have multiple cavities, we can pour in one pour. Let's say if we have 10 of these molds, just similar to this here, we created a model of the part, and then we produced a 4-cavity mold off of it. And so we just use urethane as our molding for cost-effective wise. And now we have a 4-cavity mold. So when my guys spend half an hour on the job, if he's only operating under 1-cavity mold, it takes him a long time to make 100 parts. Now with a 4-cavity mold, he's done it in a quarter of the time. So that's the reason we go for more cavities, which obviously reduces the cost to the customer. The more molds you have, the cheaper the parts are.
Great. So one other example, I think this is the last one we have. Do you want to just describe the process here and what we're seeing?
Yep. This is just a bumper plate from our automotive industry. And so what we did here is created a model of the part. Actually, I had to get a little inventive in this one and have there's an undercut section into it. So that's where we actually had to create a follow board underneath it, which in pattern making terms is just a parting line.
Is the one in the picture on the right?
The right, yeah, exactly. The one that's just hanging over the edge there. And that's, in other words, a parting line between the two. So here we just made a reverse mold off of this, and then created a mold for the follow board, or the parting line board. Did that one separately, and out of this job here we made 4 left-hand parts and 4 right-hand parts. Now we're able to make, I think we're making 250 parts of this, of the red piece, and need to be done obviously in the automotive industry as quick as possible. Within a couple weeks we can have, 250 parts done.
Okay. So I think we've got a few minutes left. So let's talk about the benefits of how implementing an Object 3D printer, how that's affected your business.
At first we did actually buy wrapper prototype parts off of other companies around in Toronto and the US and everything, and trying all the different materials in that. And it's worked out very well, so we wanted a little bit more ease and everything, so we looked at getting the machine ourselves. And at first we went the Z-Corp machine, which is a great starting point for us, just to get involved in things. We liked it other than surface texture and everything like that, but it was a good stepping stone. And now we want to upgrade our quality. We want our parts to look as good as they can. And so that's where we went to Object and brought in the Object 30, which is the quality, finish, and the accuracy. With our other machine, couldn't quite get the accuracy, but we had to pick and choose what jobs it was good for. Now with the Object 30, the accuracy is completely there within 1 to 2 thou that we can actually implement this in any job. Because even if we went to a local machine shop, we would get within 1 to 2 thou as well. So now we've saved a lot of steps just by doing it ourselves. The biggest thing too is speed. If I order it from somebody else, yes, I would have it in 2-3 days, which is incredible. But sometimes these days you need even faster. So that's why we got involved in ourselves and bought our own machine in that. Also cost too. Going with printing your own models and everything, cost is a lot better than shop costs around and everything. So, and the complexity of jobs is the biggest aspect of it. Usually when you dealt with local machine shops, you had to get your point around with how you needed this molding and everything. Well, now, and the complexity of the parts, sometimes you just can't get in there and machine square corners. So if the customer actually has to have square corners in certain areas, you've got to come up with different ideas with machining it, wire EM or die sync, which is costly as well as difficult to do and timely. At least with the rapid prototype, you can print anything up within 10 hours of time period. And the nice part, it's running overnight. So for example, we get all our jobs ready during the day, and then at 5 o'clock when you're ready to go home, you sit there and you just hit print, you go home, come back in the next morning, there's everything all ready for you, ready to just take off the support material, and we can already start making our molds. So the speed is a big thing, and the complexity, how intricate, how thin a mold, how thin a parts you can create on the object is incredible. And because of the complexity and the speed, which just makes it very easy for anybody to do.
Great. I don't know if have you analyzed, you've had your object printer now for 3 months? 2 months?
So thinking about it, actually it's probably been about 5 months now.
5 months now, okay.
I think so.
Any idea in terms of the ROI on that purchase? Do you have any idea how long it's going to take to pay for itself?
For us, we're not using it every day. We use it weekly, let's say, maybe once to twice a week. Other times it will sit for a week. So realistically for us, it's probably going to take about 4 years to get full potential. But then the other aspect of it is other jobs that we would instantly turn down because of the complexity. Intricate shapes and parts and time frame and everything. Unfortunately, we'd have to turn down a lot of jobs that came to us. Now with the Object 30, the complexity is not an issue anymore. So we're taking on jobs that we never would even dream about before.
Right.
So realistically, just that alone says in 1 year it's got itself paid for.
Great. Excellent. So 3D printing, it's relatively new to the manufacturing side of things. It's been in prototyping now. The applications in prototyping are very well established, but the applications in manufacturing are really sort of just starting to take off. How do you see 3D printing affecting your industry in the next 5 or 10 years?
Oh, it's going to drastically take off. That's why we're getting involved into it, because we're not the first ones into it, but we're middle of the row. In another 5 years, every machine shop out there is going to have one, definitely, because it's extremely valuable. So I would say in 5 years, pretty much every machine shop will have it. In 10 to 15 years, even some houses will have them in it, making any components and parts for various items.
Maybe someday we'll even be able to print your thing.
Exactly.
Who knows? Who knows?
I would love to get into that.
Okay, so just because we try to keep these short, we want to keep it under a half an hour. So let's move on to some questions. Let me just see if we've got anything here. Hold on. Okay, we've got 2 questions here. Let's start with this one. Somebody asked, why would I use urethane instead of rubber or silicone?
Properties-wise out of it. For example, silicone in that, urethane will outwear the properties on silicone at least 15 times more. And in rubber, same deal, 10 to 15 times more. Urethane is more expensive than rubber and silicone, but for example, aerospace parts and everything, where it's a high-load application, we do a lot of landing gears and everything, where urethane rubber and silicones will fail after a week. Urethane is rated for 5 years, and these landing gears that we do, they've actually tested planes that have been in service for 16 years, and the parts are still good,
still able to use, but FAA rule says every 5 years it's got to be replaced. So it's good news for us,
Right.
even though it lasts 16. But mainly wearability.
Someone else here was asking about can people make urethane parts at home?
Yes, they can, definitely. It's a different application. As you saw in one of the slides there was the ovens and everything. The materials that we use are the high-grade materials, high performance. You can get, you know, room temperature materials, which are not quite as good, 25%, you know, depending on the application. For example, forklift tires, or let's say your roller coaster wheels. They're all out of polyurethane because it takes a high heat, high speeds, high loads. You wouldn't want a home kit to make your roller coaster wheels. They just wear out instantly, and safety issues. So the materials that we use are high heat, 212 degrees to get it. It's the best properties out of it. But, you know, depending on what the application is, if it's just a bumper, you know, side of a table or anything like that, well then your home kit will do fine and it will last you long enough that for that application. But if you have a high stress application, then you want to use the more appropriate urethanes for that.
And you sell the home kits on your website, is that right?
Yes, we do.
So you can buy a kit that includes, what does that include?
You'll get an AB material. Technically in the materials there'll be 5 different components into it, but you tell us what hardness and what color you want, and then we'll make it into a 2-part system, easy access, easy usability for you as well too.
Great. Okay. So that's it for the questions. There are a couple other ones that we won't have time to. If I didn't get to your question, we'll get back to you after the session's over. But just to wrap it up, first of all, thank you very much, Sean, for being here. I appreciate your input. And
thank you.
Everybody, let me just go back there. Prothane.ca is Prothane's website. If you are interested in one of those home kits, or you are interested in having some parts made by Prothane, please go to their website and you can get all the information you need there.